We're going to conclude this brief overview of measures of variability by looking at something that we haven't really looked at so far. Namely, how do we measure the relationship between two variables? Up to now, we have been focusing on one variable at a time. But sometimes what we want to do is we want to measure the relationship that exists between two numerical variables and how much variability there is. Now, this is a topic that is best looked at after we have looked at graphs and in particular scatter plots. But again, I'm going to rely on the fact that you have seen the scatter plots before, and so you are able to interpret them at least at a basic level. So, why do we want to look at this relationship between two numerical variables? Well, for one thing, that could indicate, in some situation, it can indicate a cause-effect relation. So it may tell us that one thing is actually influencing something else. In other situations, it may allow us to make predictions. For instance, by figuring out how much medication to give to a patient, we can make a prediction about how the patient is going to do and how his or her medical levels will or chemical levels will change. So this is something that is quite important in all kinds of clinical applications. Now, the most common measure of variability that we're going to that you're going to see in all kinds of papers is something called the correlation coefficient R. Now, if you look up in the book, actually you'll find out that this has a much more complicated technical name. Just like the mean was really the arithmetic mean and not just the average, the correlation coefficient is more properly called the Pearson product moment correlation coefficient. But don't worry about that, we're just going to call it R, which is what everyone calls it. Now, why do people use this particular one, and are there other formulae to measure the relationship between two variables? Yes, there are lots of more formulae, and we're going to see that the correlation coefficient needs to be used carefully. Because just like the standard deviation, it can be misleading. But why do people use it? Well, just like for the standard deviation, it is easy to compute, to program on a computer. So its formula is very easy to implement on a computer. I'm not going to show you the formula. You can look it up in the book if you're interested. But it's a very simple formula, and it's easy to program. The other thing is it produces small values, as we're going to see in a minute. And therefore it's fairly easy to understand. Okay, it's easy to interpret. Those values are actually fairly easy to interpret, but it's also easy to make a mess without it. And it also provides very good information as long as the relationships are linear, and this is going to be a key point that we're going to come back to over and over later. So what does this correlation coefficient look like? Well, first of all, I said it's a small number. In fact, it's always a number between -1 and 1. Okay, so it's never a big number. It's always a decimal little fraction between -1 and 1. Now, if we had a value of -1, that indicates a perfect inverse linear relationship. So in other words, if we relate the two variables x and y on a scatter plot, the observations will line up perfectly on a line. Similarly, a value of 1 would indicate a perfect direct linear relation. So in other words, the correlation coefficient of 1 indicates that our data are spread out perfectly along a straight line. A value in between indicates that there is a little bit of a scatter, so the data are not exactly on a line, but they may be on a curve, or they may not have any relationship. For instance, a value close to 0 may indicate that the two variables don't have any relationship to each other. So as I mentioned, all right, I forgot about this one. Another reason why this correlation coefficient is used is that it is can be used as a measure of the percentage of variability that is due to the relation. So both variables x and y have some variability on their own, but much of the variability in each of the variable can be explained by its relationship with the other. That's going to be an important point that we're going to come back to. Okay, but again, we need to really be able to analyze graphs a little bit more and understand some of the concepts behind this whole idea of linear relationship and so on before we can do much more with correlation coefficients. So for now, take this as simply just a general, very superficial, very initial introduction to the topic.